Hi everyone, it's your man Cody here. We're out on this Friday afternoon, and I'm going to demonstrate to you an awesome scientific phenomenon we call the Doppler Effect. Now, ever hear a car, and you're on the road, you hear this car, and it kind of sounds like this? That is the Doppler Effect. Now, my friend Billy here we're in his car, and what the Doppler effect does is
Try to hurry, baby.
When you're driving down the road, the frequency will change. As it comes toward you, the frequency is higher, but then as it goes away, then the frequency is lower. But when it stopped, the frequency sounds the same. So I'm gonna have him do the actual frequency now. This is what it would sound like when you're at that rest. Go ahead.
Honk the horn.
Exactly. That's what it sounds like. Now, what I'm going to do is my mom's going to stand on the side of the road. We're going to go about 80, 90 miles an hour. And he's going to drive past and honk the horn. And you're going to hear what this Doppler effect sounds like. So, I'm going to hand this over to my mom and she's going to record.
All right, I'm ready.
All right. We'll be back in a while.
All right. Here he comes.
See the police out there, did you?
Nope.
All right.
Did you hear?
It's still recording.
Did you hear it good?
Yeah, it's really good.
Now, you probably heard that really good. Now let's talk about the reason it does that. So, picture a bug, okay? A bug in water. the bug is sitting there moving his legs back and forth. And that bug's going to create a disturbance in the water. And that disturbance is going to travel out at a given speed with a given wavelength. So, when the source is stationary, you're not going to hear much but that frequency that Billy played for you before he went off. Now, let's say the source is moving at a given speed. So, as the source is moving, it emits one wave crest, but then after it emits that, it moves a certain distance, and then it emits another wave crest. Now, in that distance, it will shorten that wavelength by whatever distance it moved. Now, it's best to explain this mathematically. So, the wavelength of a wave is the point between one crest or trough, crest being like the high point of a wave, and trough being the lower part. So a wavelength is the point between two crests, troughs, whatever you call it. Wavefronts. Let's just put it wavefronts. So you have a given wavelength, and to find out how much the wavelength will decrease or increase, you're gonna take the actual wavelength and you're gonna let's take the period. We have the period of a wave. Let's say this is like 2 seconds per cycle. That means every 2 seconds it emits a wave crest. So you're gonna take the source speed times that 2 seconds, and you should get a distance. So what you do after that is you take the actual wavelength and minus that distance you calculated, and that gives you what your wavelength is. Now, there's an actual formula to calculate the frequency that you'd hear, and I'll have to make another video on that. But the formula is observed frequency, FO, equals the actual frequency times the speed of the wave plus or minus the speed of the listener, which would be you standing there on the side of the road, divided by the speed of wave minus or plus the speed of the listener, or the source, forget that. The frequency is frequency of the source times speed of sound plus minus the speed of the observer, divided by speed of sound minus plus the speed of the source. So, let's put it this way. You're standing on the road. An ambulance comes toward you with an 800 hertz sound, and it's emitting the sound of 800 hertz. What would you hear if it comes toward you? So, what is 343 minus 30? Is 313. Now, you don't have to worry about the numerator, because 343 plus 0 and 343 minus 0 is just 343. And 343 is the speed of sound at 20 degrees Celsius, or it's about 68 degrees Fahrenheit. That's about room temp. So, you're going to take 343 minus 30, and that gives you 313. So, 343 divided by 313 times 800 will give you about 876.677 hertz, or wave crests per second. Now you do the same when it goes away. Take 343 divided by 343 plus 30, which is 373. That gives you, you do 800 times 343 divided by 373 gives you 735 hertz. 735.65 hertz. Now, this has to do with like when you're in the direct path of the source. There's like different formulas that I can't even understand when you're at like an angle to the source, and that has to do with trigonometry. But this is the basic mathematical and demo of Doppler effect. So thank you so much for watching. I hope you find this very interesting, as I did. I cannot wait to hear what this sounds like, as I was in the car when this happened, so I couldn't hear it. Thank you so much for watching. Have a good day.